All right, so your last assignment, you reviewed some pre-calculus concepts of graphing parametric equations and eliminating the parameter to write the equation just in terms of x and y. So today we're going to talk about how we can use calculus as it relates to these parametric equations. All right, so the first thing we have to define is what it means to have a derivative. So we're going to talk about the derivative of y with respect to x. All right, so this still gives us a slope. It still gives us a slope on the xy coordinate axis. So if I have, just like last time, you had a parametric equation, but it was maybe you could still graph it on an xy coordinate frame. All right, so dy dx here means exactly the same thing that it's always meant. It's the slope of the function. So it's the slope of that tangent line in terms of x and y. All right, so the derivative of y with respect to x is equal to dy dt over dx dt. And then, of course, assuming that dx dt is not equal to 0, because we couldn't divide by it or have it in the denominator if it was. All right, so that's pretty easy. We take the derivative of the y with respect to t and the derivative of the x with respect to t. The second derivative, the notation is a little bit strange. We've seen this notation before. All right, so that's nothing new. But what we're doing here is we're taking the derivative with respect to x of dy dx. Okay, so whereas here we had the derivative of y with respect to x. Now we have the derivative of dy dx with respect to x. So the second derivative of y with respect to x is the derivative with respect to t of dy dx divided by the derivative with respect to x of t. I'm sorry, the derivative of x with respect to t. So dx dt. All right, so let's take a look at how that's going to look practically. So here we have a parametric equation, or a set of parametric equations for x and y. They want us to find the first derivative and the second derivative of these, of y with respect to x. So the first derivative of y with respect to x is just dy dt. Sorry, this is a typo here. This should be dt. dy dt over dx dt. So the derivative of y with respect to t is going to be 6t minus 2. And the derivative of this x, of course, is 2 times t to the 1/2. So the derivative of x with respect to t is t to the negative 1/2. So this is the derivative of y with respect to x. I'm going to rewrite that a little bit, clean it up a little bit. I bring this t to the 1/2 into the numerator and then distribute it through. And I get 6t to the 3/2 minus 2t to the 1/2. All right. Now we want the second derivative of y with respect to x. All right. So we're going to take the derivative of this with respect to t over the derivative of x with respect to t. So the derivative with respect to t of our dy dx is going to be 3/2 times 6t, and then subtract 1 from the 3/2, so we get 9t to the 1/2, minus, we get t to the negative 1/2 when we take the derivative of 2t to the 1/2. And dx dt, this denominator is the same as it was when we calculated it before, t to the negative 1/2. And then again, I'm going to clean this up, so I bring this t to the negative 1/2 into the numerator, distribute it through, I get 9t minus 1. So that is the second derivative of y with respect to x. Right. The next example, we're asked to write the equation for a tangent line. So it's given the parametric equations x equals 4 cosine of t and y equals 3 sine of t. Write an equation of the tangent line to the curve at the point where t equals 3 pi over 4. Right. So think back. In order to write the equation for a tangent line, we need a point and a slope. Alright, so here I'm calculating the x value when t equals 3 pi over 4. So I literally just plug 3 pi over 4 in, simplify a little bit, I get negative 2 root 2. I calculate the y value the same way. The y value is 3 sine of 3 pi over 4. Sine of 3 pi over 4 is root 2 over 2. So I get 3 root 2 over 2. So here's my x value and here's my y value. Right. The derivative is dy dt over dx dt. So 3 sine of t, the derivative of that becomes 3 cosine t. And 4 cosine of t, the derivative of that becomes negative 4 sine of t. Then I evaluate those at 3 pi over 4. I get 3/4 for my slope. And then I use the x and the y value and the slope to write the equation in point slope form. And notice here I'm not going to simplify it, I'm not going to rewrite it, I'm just going to leave it in point slope form. We were asked to write an equation of a tangent line. It didn't specify what form it is, so I'm going to leave it in the form that's easiest for me and the least likely for me to make mistakes.